there's 3 files that I created, and that's just ugly. Just get out the door and just control it. So more properly, it should be in a library. So just I still got more cleanup work to do, but I just want to show you so how we may do that. So I created a file called drive, all right, and then I create individual functions here. Now, one idea is to tell it what position you want. Maybe, well, we're not going to do a full 180 degrees because the bar will prevent that, but there's going to be a certain range. I can do one function and say, you know, how many degrees from the left or whatnot, or I can say to the right, how many degrees. You got some options. So anyways, this is how you define functions in Python. Your indentations are very important. This is how you block things together. Anything that's C derived, which would be C++, JavaScript, most languages will have semicolons at the end indicating the end of the statement, and whenever you have some block that needs to be iterated through or needs to be executed separately, would be within curly brackets, open curly bracket, close curly bracket. But in Python, that doesn't exist. It's all about the indentation. So it actually ends up being cleaner to read. So, and you don't have to, worry about, oh, I didn't close the curly bracket. And that, you've encountered that, right?
Yeah.
So, anyway, so I just created several functions here. Now, I can refer to this from another file, like when we have a special file called a boot up file that, when we're powered up, we're not, maybe connected to the battery source, but we're not connected to the computer directly. We can have a special boot up file that we run, and it can load up the drive file. But in this case, I just want to test it out. So we're connected to the device. I can run it in the terminal command here. So there'll be import drive. No error. So far that's good. I can go drive. Dot. Let's go right. There it goes. Turns right. And we drive dot left.
Does that type it in there?
Oh, thank you. Thank you. Oh, timed out. I'm gonna reconnect. Unfortunately, I don't know. I think I have to import drive again because I don't know if it rebooted it. Left. Right, there we go. Alright, just going to show you where we'll progress from here. And then add other functions for drive at a certain speed or whatnot. And so I just want to show that. Alright. I'm going to show here certain things you have in the library. Again, problematic that we don't have IntelliSense. Now you have to go to Google. But here's the little junk file I have here. So I just have it in a file here. I don't know what disconnected here. I can test this. This is just there's a random. Some of the libraries are called. It has a little U in front, standing for micro. So, meaning that the full random library, probably meaning that the full random library that you find in Python is not available here. It's a subset. So, anyways, this is one of the commands it has to give a value between 5 and 10. So, urandom dot uniform. Again.
I do see you getting some IntelliSense when you highlight things, though.
Okay, hold. Really?
Well, yeah, you get some syntactical help. Especially in print. When you went to print, when you highlighted
print,
you get that.
Yeah, that's.
I'm not getting that.
Well, that's probably provided by the extension, the Python extension that we installed on our desktop. So it knows we're in a Python file.
I don't see that, but I'll look at that later. I'll investigate that later.
Whereas random, this student code doesn't know anything about that, and that's installed on this little device here. So it has to. I mean, there's different ways of handling it, but I would think the best way is to get the information from our controller or whatnot. But in any case,
Yeah.
Telson's pretty broken here. But anyways, that's the number between here, and we need it as a string. So there's a string function that will convert it, and then we can print out. So let's just and you notice I don't have this in the method. So as soon as I import this, it's going to run this command. So import.
We're gonna run that command.
And I get a number 6.16. So apparently, in order for me to clean this up, I would have to run it through a math function. I don't know. I have to Google. I would guess there would be an import math or a micro math, and there will be a math.floor or something like that. But
To limit the number of digits and
what?
To limit the number of digits
Or the decimal portions. If I so I grabbed this out of the book and I was showing that they're using that for a sleep method, like sleep between 5 and 10 seconds.
Right.
Well, maybe the micro. Yeah, the sleep's not going to take a decimal, I don't think. But anyways,
Okay.
again, without IntelliSense, you have to go to Google because maybe you could give it a 5.16 to the sleep method.
Yeah.
I don't know.
Why does it say import junk?
I named it junk.
Okay.
So sometimes I don't know what to name something. I don't want to put two brain cells together. I just like whatever. So
Import your.
so the
Right.
one I showed before, drive, import drive. Well, that's more properly named, and that's where we're going to put some other methods on there. And then ideally we're gonna have like I know there's a main.py that gets booted up. I'm suspecting there's gonna be another one. PyCon had it a little bit different. They had a boot file and then they had a main. And boot always ran before the main. I suspect that's in here because MicroPython was developed by a certain group here, and I think that will be there as well.
Is PyCom another microcontroller interpreter?
It's another microcontroller, and you can install. And they already installed MicroPython when I received the little board.
Okay, so MicroPython is a board. It's similar to what a Raspberry Pi,
Pico.
a Pico is. Okay, got it. They're
Yeah,
similar.
PyCon is very similar. In fact, I think Raspberry Pi looked at what they did and said, "That's awesome. We're going to do it."
I see.
And
Got it.
they're a little later, but not much later. All right, so that's an example there. Okay. And I don't know. Thinking of time. I was thinking of having you guys play with the breadboard here, but let's go through here and we'll maybe have a half an hour or so to work on it. So here's one. I've had some RGB LEDs in my house, so I grabbed that. The packaging on the back explained the long lead was common or ground, and then the other two are red, green, blue is around here. Anyways, so what I've done here is I wired up.
Short is ground?
Uh,
The short part of the LED, right, goes to the ground?
I think it was the long one, but it was in the documentation in the back of the package I bought.
Does it vary on different ones? Whether it's the long or short that goes to the ground?
There might be a standard. I haven't been in electronics for a couple decades.
Because I thought the short went to the ground.
Anyways, so if you look here, I've wired up to my board here, which kind of is friendly labeled. I know it's wired up to pin 19. David, can you see? So we got all the pins labeled here, and they're kind of mirrored over here and also to here. So when you read the labels, I'm going to, for pin 19, you'll see pin 19 along here, and that matches over to this one.
I have one question.
Yes.
How come there's 2 rows on each side?
I designed it that way. My thoughts was, okay, someone will just plug in the Raspberry Pi Pico here, and then I'm going to produce other little PCBs that you can plug in. So the next one would be the motor controller, or the mobile PCB that I'm going to create, which will allow you to plug in a battery to it and then control the motors. There's, I don't have it out here, but we'll get, I think next week or the week after that, we'll get into a motor controller.
Okay.
And so it was I'm gonna design it to have that, and
Just don't
be
because
great.
those 2 strips of holes, if
Yeah.
you will, on the
Yeah.
black plastic, those aren't those duplicates of the pins here on?
Yes,
Right.
That's why I don't. So this gets plugged in here, and this is connected to the same ones on this one. This one's the same one that's connected on that side. Same with this. So they're all 3 columns. They're all connected to the same pin.
Okay. Are these 2 columns connected to the pins on this side?
This one is connected to this connector right there. If you look at the wires, they're very simple. They're just kind of going straight across.
Right.
So this one, right, this top one is
Yeah.
connected to this top one.
Right.
This top one is connected to that
Oh,
top
okay.
one.
All right.
And repeat the pattern on that one.
Okay.
So,
I see.
Yeah.
So essentially, this row, these 2 rows are common,
yeah.
and these 2 rows are common.
Yep.
Okay. All right.
And then common with the one.
Common means
Meaning
ground?
they share
They're
the
sharing
same.
connection.
Same
They're the same
connection.
thing.
Okay.
So, and that's how I've wired it up. And it actually was a little bit easier than using
It's like
the
cross-
breadboard and
Yeah.
then going to page whatever, get the layout and look and start counting the pins. I don't have to count because
It's like
the
a
label's
patch
close
panel.
enough.
It's like a patch panel, a cross connect.
Anyway, so this is wired up to pin 19. I put a 220 ohm in there. It's not as bright as I was expecting, but all right, let's just run this. And so this is uploaded, so I should be able to run it. This one will be, I wired up, it's actually blue. Even though I named it green because I connected the first one to green. Darn it, what happened? Sorry, the import. Wake up, Mark, wake up. Imports. RGB, LED. Connect.
Oh, do you have to be in that file again? You have to
No,
click on
we're in the
file?
shell, so I should be able to just import. RGB. It could be that I wiped it out from. Maybe I have to upload it. I'm gonna try to upload it. I can't sell that on the PyCom as well. Sometimes it wipes things out. All right, now it works. Okay.
Why does it work now?
Because he uploaded it.
Yeah, it got wiped out from the RAM there. It's got flash, so it got wiped out from flash as well. Maybe I have to upload all of them. All right. What's in it? Oh, and then we got green. It'll be blue. There it is. I want to fix that. Move the resistor over to the next pin over there, but that's just how it is right now. All right.
Okay, so you just addressed pin 19. You gave power. You said power go on. Pin 19.
Yep.
Okay.
Since I got a toggle, I know if I want to turn it off. I do the same thing. I dislike the issue with. I'll just turn it off again. Now it's off. Unfortunately, I can't use my upper arrow to bring up the last command that I had typed in. I find that convenient, but it's not there. All right. And so if I wired up the other two pins, I can control all three colors, and if I turn them all on, they'll be white. If I turn just the red and the blue on, it's going to be purple. So, all right.
Can you turn all three lights on?
Yes, I just have to physically select another pin. To do it right now, I have to grab another 220 ohms, then get a wire here, a couple more. Maybe I should just show you.
I was just wondering. You don't need to do it. I was just curious. Okay.
It'll be easy. We could do it.
Did you have to do the resistor? Would it blow the LED if you did not?
I tested it and it didn't blow. But
You recommend somewhere along the line somebody recommended to put a resistor in there?
yeah,
Okay.
typically for LEDs, it will draw too much current and can damage the device. They may put some checks in there, or
Visual Studio Code.
I'm not sure. But we'll do it right now. It's not recommended. But
Otis Boykin
But
invented the
It's
resistor
okay. I'll take your word for it.
and the
I just
pacemaker.
want to.
But generally you're supposed to.
Good.
So.
All right, good.
Alright, I'm there. Now what do you want me to do?
Oh darn it, I'm missing stuff.
Oh yeah, I think you could do that, yeah.
Okay, let's.
Windows?
Now, hopefully it's still connected. Where's my glasses?
No. Find the right next to Visual
VDPY.
Studio Extension Python.
Clicked on that one.
Visual Studio Extension Python.
Alright.
IntelliSense Python?
Yeah, my connection got disconnected.
But wait for it, hold up. Just keep
And I brought it
stay
over
there
here.
for,
Now
Visual Studio 2. Visual
let's,
Studio 2 to load.
talk about potentiometers and darn it.
Potentiometers.
So it's like a voltage divider where you can. It has an internal resistor.
Variable resistor.
Yes, very good. And it allows me to change the voltage on the output on the signal here. And I mentioned we have an analog to digital converter. And let's just see if we can read values from this. So don't worry about these two lines. I'm not using this yet. Just want to read through the values. So I'm going to upload this. And so I basically have a ground to the potentiometer. We've got a power, which is 3.3 volts being supplied to it. And then we have a output of variable voltage based on our setting of this potentiometer, which has a variable resistance there. So based on that, you're going to have a different voltage. And
the black's the variable?
Black is ground, red is power, and
power.
Orange is the signal.
Orange is the signal, so the same as the servo motor.
It's typical, yes. In fact, this one is the same. So that's why I chose those colors. Anyways, so let's just read it. So we set up the analog to digital converter. That's a method on machine. You just have to know it. You can't use IntelliSense, unfortunately. And you chose which pin, so I've plugged in pin 26.
Pin 26.
All right, and then I've uploaded this, right? I just did.
Okay.
And I'll just do it again, make sure. And I'm gonna import this, and it's gonna do what it will do at that point. David, were you paying attention?
It's gonna import.
It will do nothing.
Program.
In the shell, and I import it. I just imported the library. I need to call the method. So
The method.
well, the method called read voltage. So import
Import.
VD. The reason I name it VD is I got tired of typing. All right, so it seems to be imported, no errors. And then I go VD dot read voltage. Again, yeah, I probably should shorten it as well.
Okay, on the side.
And so it's going through a endless do loop because it's while true. Well, it's always true. And so it's just going constantly again and again and again. No pause in there. I think I showed last time. We generally like to put a little sleep in there so it doesn't doesn't force the processor to keep on running as fast as it can. You know, it's kind of like what's an analogy? I mean, you know, you're expecting someone to come to the house. Well, you don't check the door, open the door, check that someone's there, and then close it. And then a second later, open it again, close it, open and close it. That was actually an analogy I was going to kind of explain about interrupts, if we can get to that point. Anyways, so let's see if this works. It did work. Let's see if I wired it up correctly. So, all right, there it is. And it's basically it's reading through, and it's going to be a value between 0 and 65,000. All right, so I'm adjusting this. You see the numbers. Gets up to 65, and then I can bring it back down.
What is the significance of the pound sign LED dot duty? Is that marked out?
Yeah, I'm going to show that next.
Okay.
And
Am I supposed to see a sleep anywhere?
It's going down. It was almost a 0.
Because I don't see the sleep you tell it.
Between 200 and 65,000.
Yeah, it's not expected to get down to 0 because of issues of potentiometers. There's always going to be some resistance.
Okay.
Where is the sleep you mentioned? So it doesn't.
We don't have
full
sleep
speed?
in this case. I'm just letting it run as fast. Okay. All right. Let's stop this. All right.
That's pretty cool. That it reads that analog signal.
All right. So now we're going to use that value 0 to 65,000, and we're going to use that to our set up our PWM onto pin 19, the same pin that we were using before, and we're going to adjust what percent of time it's at the 3 volts versus the 0 volts, and so we should be able to change the brightness. It'll be effectively we'll be able to change the range of the voltage between 0 and 3.3 volts. All right, so let me comment here and send the frequency. We could change the other things, but
ID
that's not as
frequency
important.
1000.
All right, let's upload this.
Upload.
Give me a little error. Current file not saved for the. Don't know what happened. I'm gonna upload again just to make sure.
Upload again.
All right, let's import VD.
Import VE.
And VD dot read voltage.
How did you connect the Pico to the Visual Studio Code?
Well, once you're physically connected, you have a command. You need Pico Go extension installed.
Okay, right.
All right. All right. Let's see. This should turn on a light, and we should change the brightness. Oh, it is on. Hard to see. Let's see if we can change it.
Yeah.
There we go. Now it's bright.
Looking great.
Now it's dim. Bright, dim. And that's
Cool.
so.
Bravo.
Okay. Stop that.
Potentiometer, light emitting diode.
So
Let me ask you, I'm sorry, I'm following your code now more intently. So I get the LED dot frequency 1000, that means, that's the color code? That's
Well, we're setting up a pin, pin 19
I get that.
for PWM, and you know how often is it changing back up and forth the frequency of that. I bet you if I changed to 500, we wouldn't even notice any difference. It's just, you know, most devices.
What if we
can't see
changed
that.
it to 100?
Probably not as than that. I'm sure that there'll be. Yeah, I haven't experimented with the different notes, but.
And then the read voltage is a routine that, while true, which is always, so it's going to print out the number that we saw at the bottom, and then it's going to LED.duty, that's feeding the.
So this one we saw when we printed out was between 0 and 65,000.
Right.
This method apparently it knows that range, and it's taking a percentage of that. And it's helping it figure out what percent of time it's going to be high versus low.
Okay. Cool.
Okay.
This one goes bug. So what happens after installing?
The extension?
Yeah.
I would close out